Opties! Today we're diving deep with some scale factor. There is a volume emblem, which I thought was quite fitting because scale factor is getting bigger or smaller, kind of like volume, you know, increasing the volume or decreasing the volume, but all the while it's still volume, just like the shapes we get from applying a scale factor. That's in a dilation and the shapes never change, just like whatever you're listening to doesn't change. So let's go ahead and take a look. So we've talked about scale factor before and how it's some sort of number that tells us how much bigger or how much smaller an image is getting from the pre-image. So we're just talking about it a little bit more in depth here. We've got 3 different formulas based on what you want to find, all dealing with scale factor, and we have a point to ponder for these. All image and pre-image lengths which are in these 3 formulas must be corresponding. And these formulas work for no matter what type of scale factor we're dealing with, whether it's a reduction or an enlargement scale factor. So looking at this image here, we've got a pre-image, which is our green, and then an image, which is our pink. We know that because the pre-image doesn't have the tick marks on the letters like our images always do. So based on this, we have an enlargement scale factor. Let's say we wanted to find the scale factor and it wasn't so obvious by just looking at it. It was some like crazy huge numbers or something, or some decimals or something that you wouldn't want to just kind of eyeball. It might be pretty easy to tell that the scale factor is 2 here, but we can always use this formula. Scale factor, I'll write SF, is going to be equal to the image length divided by pre-image length. And you can choose any old image and pre-image length as long as they're corresponding. So let's do 4 over 2. We know it's the image over pre-image, and that should be equal to 12 over 6, which should also be equal to 22 over 11. We know this should work because similar figures like these, because we know it's under a dilation, have proportional side lengths. And for all of these, we get 2. And what we could also have written is that A prime B prime over AB is equal to B prime C prime over BC is equal to A prime C prime over AC. So here's how we could also write it in letters. Let's say we wanted to find an image length and we knew the scale factor in the pre-image. We could just multiply these two. And this equation, along with this next one, just come from rearranging the original scale factor equation. So we know the scale factor is 2. Let's pick a random pre-image length. So we know it's image over pre-image, so we could use 2, 6, or 11. How about we just use 2? And that means 2's corresponding image length should be 4, which matches up perfectly. We could also do it with our other lengths. The 6 should give us an image length of 12, and the 11 should give us an image length of 22. So the way we could write that is A prime B prime equals the scale factor, which we like to call K lots of times, so let's do that, times AB. And we've seen this notation several times before. We've got B prime C prime equals K times BC, and A prime C prime equals K times AC, where K is the scale factor. In this case, we know it's 2. Finally, if we wanted to find the pre-image length, we could take the image length and divide it by the scale factor. So this is assuming we knew the image length and scale factor, like a question was asking for the pre-image length. So the scale factor's 2, the image lengths are going to be the 4, the 12, and the 22. So if we started with the 4, we should get 2 here. If we went with the 12, we should get 6. And if we went with the 22, we should get 11, which we No, checks out. So we could also write this using our letters. We could write A prime, B prime over K equals AB. Then B prime, C prime over K equals BC. And then A prime, C prime over K equals AC. And that's like taking this equation and dividing both sides by the scale factor to get the pre-image by itself. Let's look at some examples where we have dilations with coordinates and using that scale factor with coordinates. So our point to ponder says the scale factor of any dilation centered at the origin, this is very important. So centered at the origin, point 0, 0, can be found by dividing a pre-image coordinate by its corresponding image coordinate. So scale factor is pre-image length over image length, and we can do this with the coordinates if we're centered at the origin, because the coordinates do tell us the distance or the length, because they're just starting at 0. The dilation rule can be written as follows if the scale factor is k. So xy goes to kx, ky. So you're just multiplying each coordinate by the scale factor. So on number 1, if we want to find the scale factor, we can just divide the coordinates of the corresponding points. So A prime over A should equal B prime over B, and both of those should give us K, the scale factor. So let's look at that. 2 -6 divided by 5 -15. Now this looks kind of weird. You might just want to write it as 2 divided by 5 and -6 divided by 15 for your A's, which should be 4 divided by 10 for the X coordinate of your B's, and -2 divided by -5 for the Y coordinate of your B's. So we have 2/5, and that is actually what you get for all of these. Oh, this should be a -15, and this also gives us a positive 2/5, and so do both of these. So the scale factor is 2/5. So we could write the rule xy goes to 2/5 x, 2/5 y. Now let's look at it where we're actually given the pre-image and we want to find its image under a given scale factor. So the scale factor is 4. So that means we can write the rule xy goes to 4x, 4y. And we know we can do this because it's centered at the origin. Now it doesn't actually say that, but if it doesn't tell you, then you assume it's centered at the origin. So if we find all these coordinates, we can write them out. That will help. We can also just use the grid, but it's good to actually have the numbers as well. So we got 1, 2, 3, 4, 5, 6, 7, up 2, so 7, 2 for that coordinate. This should be 7, 2, 3, 4, 5, and this one should be 2, 2. And we can label them if we want A, B, C, just to keep it steady. So A prime should be 4 times 2, 4 times 2. So again, we're finding the actual new coordinates. So we have 8, 8. B prime should be 4 times 7, 4 times 5. So B prime is 28, 20. C prime is 4 times 7, 4 times 2. So C prime is 27, 8. And those are our coordinates. All right, Opties, that's it for scale factor. See you next time.